Hello friends, in this video we will discuss some questions which were asked in NEET 2020. The paper code is E1. However, I have just copied the questions on this slide itself for your reference. Now, if we consider question number 136, it asks for which one of the following Bohr model is not valid. We know that Bohr model is valid only for single electron atoms or ions. So it is obviously valid for hydrogen atom. Now if we consider singly charged helium atom, helium has atomic number 2. So when we convert it into helium positive ion, it will be left with 1 electron, and hence Bohr model will be valid for this species. Now if we consider deuteron atom, now deuteron is an isotope of hydrogen itself, hence it will also contain only 1 electron in its first shell itself, hence we expect Bohr model to be valid for deuteron as well. Now if we consider singly ionized neon atom, now neon has atomic number 10. It is an inert gas. So out of 10 electrons, the electronic configuration is 2,8. So valence shell has 8 electrons. So if we obtain a singly ionized neon atom, it will be having 7 electrons in its valence shell. Hence, Bohr model is not valid for this ion. So our answer should be, for question number 136, answer should be 4th option. Now we come to the next question, question 137. Here we have to compare contribution of electric field and magnetic field to the intensity of electromagnetic waves. So it will be better to remember this basic concept that both electric as well as magnetic field contribute equally to the overall intensity in any electromagnetic wave. Peak value of electric field and magnetic field variations are related through this relationship, E naught being the peak value of variation in electric field intensity, B naught being peak value of variation in intensity of magnetic field produced in a region when electromagnetic wave passes through any given region. So magnitude of magnetic field intensity variation is much smaller compared to variations in electric field intensity. However, it can be shown that both the fields contribute equally to the energy when we consider the overall intensity of electromagnetic wave. So its answer should be second option, that is equal contribution of electric field and magnetic field components. Now, question number 138 says, it basically wants to know what are the possible values for Brewster angle for any particular interface. Now, according to Brewster's law, if a ray of light is incident from a rarer to denser medium and it is incident at a particular angle, called Brewster's angle, then at this angle reflected ray and refracted ray are mutually perpendicular. And we arrive at the relationship that tan of Brewster's angle of incidence is equal to refractive index of the denser medium with respect to rarer medium. Now, since value of mu is always greater than 1, hence you can expect IB to be taking values greater than 45 degrees but less than 90 degrees. Clearly, IB cannot extend beyond 90 degrees. So correct option for question number 138 is third option. Next question is based upon gas equation, ideal gas equation. It says that a cylinder contains hydrogen gas at pressure of 249 kilopascal. So pressure of the gas in the cylinder is 249 kilopascal. So these many newtons per meter square. Temperature, we convert it to absolute temperature. So this becomes 300 Kelvin. Universal gas constant is given to us. We have to determine density of hydrogen gas in the cylinder. Now, from ideal gas equation, we have PV should be equal to nRT. V is for volume of cylinder and represents number of moles of the gas present in the cylinder. T absolute temperature, R being the universal gas constant. Now, number of moles will be equal to mass of the gas in grams divided by molecular mass. let us say that is also taken to be in grams. So rearranging this relationship, we can say pressure into molecular mass in grams divided by RT should be equal to mass of the gas in grams divided by volume of the gas. Now, if I want to find out density in kg per meter cube, which are the given options, then I will need to convert both these masses into kilograms. So, molecular mass of hydrogen gas in kilograms will be 2 into 10 raised to the power minus 3 kgs. And that should give me density in kg per meter cube. When you put in the values and simplify, you will easily be able to arrive at second as the correct option. So answer comes out to be 0.2 kg per meter cube. Next question is based upon refraction of light through a triangular prism. So suppose the question says that we have a small angle prism and the ray of light is incident at such an angle that it emerges normally from the opposite surface. For it to emerge normally from the opposite face, it must be striking the face AC at 90 degrees so that it can emerge normally from this face. Now, at the face AB, suppose I is the angle of incidence. Now, this becomes angle of refraction at the face AB. From the triangle ADE, we can easily identify that angle R will be same as angle A, because this angle is 90 degree and this angle is also 90 degree. So this angle becomes 90 minus R, and this is also equal to 90 minus A. So in whatever manner, you can easily convince yourself that angle R will be same as angle A, which is the angle of prism. Therefore, applying Snell's law, at the face AB, we get refractive index is equal to sine I upon sine A. Now, since it is given that angle of prism is small, so assuming all the angles to be small, we can approximate sine I by I itself, sine A by A itself. So that gives us angle of incidence as mu into A, and hence option 3 is the correct option. Hope you find this solution useful. Thanks for watching.